Hi there, Mr. Sutton here, bringing you another lesson on systems of equations. This time we'll be using the substitution method. Specifically, we're going to solve systems algebraically rather than graphically using this substitution method. And for the real-life application, we're going to figure out what time one runner will overtake another runner. Let's kick this one off with a real-life problem. Let's say I challenge you to a 1 mile, that's 5280 feet race. There I am. I'm going blazingly fast. My shoes, in fact, are on fire. I'm going so fast. And I'm going 10 feet per second. Now, you're even faster than me. I mean, I'm pretty quick, but you're going 13 feet per second because you're younger. Now, nobody really just wants to watch you beat an old guy in a race. So to make this interesting, because I'm older, I'm going to get a 1,218-foot head start. Your task for this warm-up, let's let x be the time since the race started, and y will be the distance traveled. Write an equation to say how far each of us has traveled after x seconds. Pause the video, give it a shot. All right, let's see what we came up with. Now, you're a little bit easier on this regard. Your distance, y, is just going to be your speed, 13, times the time, x. Me, I'm kind of similar. I'm going to be y equals 10x, but I'm also going to have this 1,218 feet added to my distance. So at time 0, I've already gone 1,218 feet, and I'm feeling pretty good about it. So the question is, you're going to catch up at some point, so how long will it take you to catch up? And how far will you have run at that point? And since the race is only 5,280 feet, who wins? So let's start with what we already know about solving systems of equations. We know if we have two equations, we can graph them and see where they intersect. How would that help us here? We could graph these. So we have y equals 13x. That's a y-intercept of 0 and a slope of 13. Looks something like this. And then we have y equals 10x plus 1,218. Y-intercept is, somewhere up here. We're just sketching this. And the slope is a little less steep than this 13. So we're going a little less steep, and at some point we're going to cross. And if we could only figure out what that intersection point was, we'd already have solved the problem. The difficulty here, this works great if you have a graphing calculator, but what if you don't? And even if you do, you still have to mess with the window to figure out that spot. If you're just using graph paper, then you're just kind of estimating, and you might not be as accurate as you need to figure out who wins a race. So we need something else. So we can see for this problem that trying to solve this by graphing is like trying to perform a delicate surgery with a sledgehammer. So instead, we're going to solve this algebraically using the substitution method. So first step on this, if it hasn't already been done for you, is you need to get one of the variables all by itself in one of the equations. Now looking at our equations, we have y all by itself in not one, but two equations. So they more than did our job for us on that first step, but it's not always done. Second step, once you've got that variable isolated, you have to substitute for that isolated variable in the other equation. So in other words, y is the same as 13x. So wherever I see a y, I can replace that with a 13x. Oh, hey, over here there's a y. That means I can replace this y with 13x. Because the y's and the x's, they are the same y and the same x. So whatever y equals over here, it also equals over here. When you're doing this, so we're going to have 13x plugged in for y. When you're doing this, I recommend that you label your first step. We're going to see that this is going to take us kind of all over the place in terms of our work. So it's a good idea to tell the reader what your first step is so that they can follow stuff. All right, once you've got that substituted, you're going to go ahead and solve the equation for whatever variable's left. Note that when we substituted for y, we no longer have two variables in one equation. We just have a single variable, at least one type of variable. So we can subtract 10 from both sides and then divide by 3. I'm going to use the calculator for this one. So 1218 over 3 is going to give us 406. So that is the time it takes you to catch up to me in that race, if this was that real-life problem we were just doing. Now, at what distance do you actually catch up to me? To figure that out, we have to do what we always do when we're solving a system of equations, and that is plug whatever that variable you just found is back in to figure out the other variable. We know that x is 406, so we'll substitute that back for the x in one of the equations here. It doesn't matter which one, although this one looks a lot easier. And Multiplying that by 13 will give us the y value. I'll use the calculator for this too. So plugging that in, we get 5,278. So that means that our point, if we were trying to find the point of intersection for this, would be 406, 5,278. Now, in terms of our real-life problem, the race was over at 5,280 feet. Oh, hey, look at that. You caught up to me 2 feet before the finish line and then passed me. Good for you. You won. Congrats. The homework is still going to be due tomorrow, but you can at least feel good about yourself for beating an old man in a race. Here's another problem that we're going to use the substitution method on. Pause the video and see what you can make of this one. All right, let's see how you did. So again, we're going to try to isolate one variable in one equation. This variable, x, is already all by itself. Why reinvent the wheel, right, if they're already giving this to us? So we're going to substitute y plus 1 for the x over in this equation. And as always, I label my first step here. So this is going to be 3 parentheses, y plus 1, close parentheses, plus 4y equals negative 11. Very important to use parentheses when you are substituting. Distributing that, we've got 3y plus 3, and then we can combine like terms to get 7y plus 3. Subtracting 3 gives us negative 14 on the right. Dividing by 7, we got y equals negative 2. Don't forget to plug back in. So this equation where the variable is already isolated that we're looking for, let's just plug the negative 2 in here. So that'll be x equals negative 2 plus 1, or negative 1. Our point then, our solution, is negative 1, comma, negative 2. Here's our last problem. Pause the video and try this, get as far as you can. All right, let's see what we came up with. Now you might notice that we don't have any isolated variables in either of these equations, so this is different than the first two examples in that respect. But let's see if we can isolate one of these variables. Now when you're doing this, you need to be selective. Pick an easy target. What would be the easiest variable to isolate? In which equation would it be in? I would go for this y over here in the second equation. It still has this negative next to it, but it doesn't have any other kind of coefficient. So this looks like easy prey here. So we'll start by subtracting this 10x from both sides. And then negative y is not good enough. We need positive y by itself, because we're going to be substituting for the positive y over in this equation. So multiply everything by negative 1. That'll be y equals 3 plus 10x. And now this is what I can substitute over here. So we've got 4 parentheses 3 plus 10x. Distributing that, we've got 12 plus 40x. And then combining like terms, we're going to have 55x on the left side. On the right side, we can subtract the 12 to get 11. And now we just have to divide both sides by 55 to get x. 11 over 55, that's going to actually reduce to 1/5. So that's our x value. Now the nice thing about isolating this variable for this first step here, first or second step, is that once you've isolated this variable, you can then go back and plug whatever value you find for the other variable into this equation. And you've already got y all by itself. You just have to figure out what the right side is. So this will be 3 plus 10 times 1/5. 10 times 1/5 is 2, so 3 plus 2 is going to give us 5. So 1/5 comma 5, our final answer for that one. That just about wraps it up for solving systems by the substitution method. In our next lesson, we'll take a look at how to solve systems algebraically by another method called the elimination method. Until then, this is Mr. Sutton signing off.